YouTube channel and wanted to post videos regularly, but I couldn't. How do I apologize my viewers? Shh. Why so much demand these days? Okay. Let me do this. Let me start recording. Wait, the recording is already on. So you saw me doing all this? I'm sorry, I didn't notice that. Or did I? Is it just drama? Anyways, I'm sorry about that, and from today on, I'm going to post videos regularly. So, today's question. Okay, we are given two strings of same length, s1 and s2, and then we have a base string, and we say s1 of I and s2 of I are equivalent characters. Like here, if we have A, B, C and C, D, E, so A is equivalent to C, B is equivalent to D, and C is equivalent to E. And we have these relations: reflexivity, symmetry, and transitivity. Okay, now so using these equivalence relations, we have to find all the equivalent strings of the base string, and out of all of them, we have to find the lexicographically smallest string. Okay, sounds cool. Now, one thing that you should always look out for is when you have transitivity. Like if A is connected to B and then B is connected to C, and you automatically want A to connect it to C. Now this is something that a union find data structure can do perfectly. So because we can connect A and B, and then we can connect B and C, then the whole union gets connected. So directly we can say that A is connected to C. So that would be one of the best data structures to use here. So we can use these equivalence relations, and we can create a union find, and then for every string in the base string, we can find some other character out of all the characters that are related to this base string character. In the union find data structure, we can find the smallest, and we can do that replacement. I think that would work, and the constraints are pretty weak, so we don't have to think a lot about the complexity. So if you guys don't know about union find, I highly recommend you to do some research about union find. I'm going to I'll start implementing it. So I'm using this I'm using a dictionary as a union find data structure, and then I have this find function if x is not in and if it is a leader of the union, then I'm going to return it. Else I'm going to find the parent of x. I'm going to return that. Okay. And then let me quickly write the function for union as well. As the constraints are weak, we don't have to implement path compression, and okay, we already implemented path compression, but we don't have to implement rank by union, because the constraints are pretty weak and I'm very lazy. I'm a lazy person when it comes to weak constraints. So I'm just going to write a basic union code. I'm just going to move forward. Okay. Alright. Ah. Okay. Well, I was thinking, instead of just no problem, I can do that at the end. It's okay. So for each so for each relation and string s1 and s2, I'm going to do union of val and s2 of int. Okay, so I've put all these relations, I've assimilated all these relations into my union find data structure. So now I have my data structure ready. So what I'm going to do is, for each and every okay, I'm going to create a, I think I'll create a, I'll create a data structure of called as members, which would be a sorted list kind of thing. Oh, okay, I don't have to. I'll just create a default dict of, I'll create default dict, or I'll just create a normal dict, and for each leader, for each x in parent, I'll see if parent of x is if it is not in members. So I'll first write the code and I'll try to explain what I've done. Or my code my code is pretty easy to understand, so you can do that. So what I've done is I've created this data structure, which is a hash map, which is a dictionary, and in that dictionary the keys would be the group leaders of the unions, the union leaders of the unions, and the values would be the smallest character, lexicographically smallest character out of all the characters in that union. You're getting it right? Right. So what I'll do is, now for I'll have an answer, and for each string in for each character in base string, I'll first find its leader. So leader would be parent find of x. I think that's a better thing to do. Here I have to do, right? Just to be cool. No, just to be clear that the parent is consistent with the situation. Okay. And now I'm going to append the smallest character in that union that I can find using members, and I'll return the answer. Let's see if it will be correct in the first attempt. Okay, I've got an error. This is not. No. Good. Q is not here. Okay, just to find what there is number of reader. How can it be possible? I'll do one thing. I'll just do this thing. I'll just okay. Okay, so U is not here. Wait, that I can do. So for each string in base str, I'll just find of x. So that the thing is, we have here in Python, when you don't have for a basic dictionary, when you don't have, it shows a key error. It does not show any it does not show any default value. So we can do this. Oh, what? I think I should do this here. So I'm just putting the default value as itself. Oh yeah, that seems to work. Do I submit or do I proof check? Oh come on, let me submit. This is not a contest. But you should never do this. You should never submit without once going through the whole code. You should never do that. So for a brief explanation of what I did in my code, I have this parent parent dictionary, which would be my union find data structure, and I have this find, and I have this union, and then for each relation I'm doing that union thing, and then I have this dictionary called as members, in which I have, so members defines the smallest character of every union, right? So the key would be the leader of the union, and the value would be the smallest character in that union. So I've populated that here. After that, in the base string, for each and every character, I found its leader, and then I'm finding the smallest character in that union, because I can use transitive relation and other relations to reach that lexicographically smallest string, because it is connected. I'm returning that answer. So what would be the time complexity of this? Okay, time complexity little complicated. Let's start with space complexity. So I have this dictionary. So there would be at most O of n entries in this, and then these members would have O of n entries. So the space complexity would be order of n, and the time complexity would be the amortized time complexity. The time complexity of union find data structure is inverse of the Ackermann function, but you can think of it as an amortized constant time complexity data structure. So so for each and every relation, I'm doing a find, and I'm doing a union. So it would be n into or n into of 1 plus n into of 1 plus n. So the time complexity would be n as well, n into Ackermann function, which would be eventually when you have so many things, so many so many inputs, then the amortized time complexity of Ackermann function would be constant. And yeah, so O of n, O of n. Anyone has done it better? Did anyone do it in login? Why in login? We're not sorting it anyway. Yeah. Oh, if I did any mistakes in calculation of time complexity, please comment down below. And yeah, bye. See you tomorrow.